This is lesson H3. What are trigonometric ratios? At the end of this lesson, you should be able to define trigonometric ratios and identify the trigonometric ratios by looking at a diagram. So, first off, what is trigonometry? Just a brief history and translation. Trigonometry comes from Greek, trigon meaning triangle, metron meaning measure. It is a branch of mathematics that studies relationships involving lengths and angles of triangles. The field emerged during the 3rd century BC from applications of geometry to astronomical studies. You can skip this slide. So first we're going to look at the 3 special trigonometric ratios. These 3 ratios are sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. Just a reminder, these only work with right triangles, and they're only used for the acute angles. We don't use them for obtuse angles, and we don't use them for the right angle in a right triangle. And the ratio, usually we round to about 4 decimal spaces. So when working with these ratios, we usually label the sides like this in the diagram. The hypotenuse is the longest side across from the right angle. The adjacent side is the side next to the angle you're working with. So for example, if you are working with this angle here, this is going to be your adjacent. This one would be your opposite. It is opposite of the one we're looking at. Now, the Greek letter theta is often used to represent the angle we're looking at. So in this case, we would put theta in this angle since that's the one we are looking at with our adjacent and our opposite. If it was over here, this would become the opposite, and this one would become the adjacent. So just be careful to notice which angle it is specifically you're looking at when deciding which ones to use for opposite and adjacent. So identifying the cosine and tangent for ratios for angle G. Sine of G is our opposite divided by our hypotenuse. It's the ratio between opposite and hypotenuse. So I would take my opposite and divide it by my hypotenuse. So my ratio is 15 over 17. When I look at cosine of G, I'm looking at the ratio between the adjacent and the hypotenuse. So the adjacent side to G is length 8, and my hypotenuse is, again, length 17. So I get the ratio 8 to 17. And finally, tangent is the ratio between the opposite and the adjacent. So I would be looking at the opposite, which is 15 again, and this time instead of putting over the hypotenuse like I did in sine, I put it over the adjacent, which is 8. And we have some great mnemonic devices for helping us remember the formulas for sine, cosine, and tangent. So sine, we look at the S in sine, the O, and the H, and we get so. Cosine, C in cosine, A in adjacent, H in hypotenuse, and we get ka. And then T in tangent, O in opposite, A in adjacent, and we get toa. So usually we put this together for the mnemonic device, SOHCAHTOA, SOHCAHTOA. So again, SOHCAHTOA is sine, opposite, hypotenuse, ka, cosine, adjacent, hypotenuse, and toa, tangent, opposite, adjacent. So let's find the following ratios, and we'll leave them as fractions. Sine of A. So we're looking at angle A over here, and sine again is opposite over hypotenuse. So my sine of A will be 12 over 13. Tangent of B, so now I've moved over here to angle B. Tangent is opposite over adjacent. So I have 5 over 12. Cosine of B. So we're looking at excuse me. So we're looking at adjacent over hypotenuse. So my adjacent to B is 12, and my hypotenuse is 13. Notice the sine of A and cosine of B are the same. My sine of A and my cosine of B are the same. And then for tangent A, I have opposite over adjacent. Notice that these, my tangent for both of them, would be opposite. So we're not going to get into this in this lesson, but just so you know, the reason we're looking at sine, tangent, and cosine and their related ratios is because we can use these to help us find angle measure. So if you don't have a given angle measure, but we have the side lengths, we can find side lengths from these different ratios. But that will be for another lesson, another day.